So you came for the Docker talk, right? I hope so. I will start with small, questionnaire in the beginning. I need to know who is listening to me today. So who came for Docker? Just Docker. Okay, great. Who came for OpenShift? Few of you. How many developers do we have? Yes. And how many operation guys? One. Don't be shy. Don't be shy. They will not kill you. I'm glad you came, and we have like 15 minutes, so I should be quick. My name is Marek. I work in RedHat at the OpenShift team. I am a Ruby enthusiast. I like JRuby, but I also work with Java. And today I want to... Oh, I forgot to put the footer there. Sorry. And today we should talk about Docker and about OpenShift's future, because OpenShift is moving up to Docker, and we will be using Docker internally. I'm glad that so many of you came here today, and I hope you are enjoying your lunch during the session, and I wish you good appetite. So let's start with some history and what actually the Docker thing is and what it does. So some time ago, it started with virtualization, right? So the people started to put many operating systems on one machine and virtualize the hardware. However, virtualizing hardware has some overhead. So there was idea just to virtualize the kernel calls. And this concept was called containers. And because people started building these things, it was possible to build systems or something that was called platform as a service. Who knows what is platform as a service? Who is actually using it? Not many of you. It would be very interesting to see why you are not using it. But generally, platform as a service is a thing, it's a service that tries to abstract all the operations parts of the deployment process from the developers. So developer can focus on developing the application. The developer takes his code and pushes the code somewhere into some service. And the service will configure the environment, will start the servers, will build the code eventually, and will deploy it into some application server or whatever other technology you use for deploying it. And this is abstracted, it's a black box from the developer. But operations see what's happening there, developers don't. And the developer sees just the result, the running application. So that was the concept. One of the first big providers was Heroku. As you as Java guys, you probably know CloudBees, right? And one other is OpenShift, that's our service by RedHat. And one of the other services was called .cloud. That was founded by Solomon Hayek. And they have been building their own platform as a service with all the stuff of deploying some different services. But I'm not sure why. I think they didn't have the traction just to keep the whole business. And they extracted their containers into something that they called Docker. And they made it public, available to everyone. And it got popular. People started using it. And nowadays, it seems that Docker will be the next standard for containers. When we were starting our platform as a service 2-3 years ago, there was no standard. Everybody was using their own methodology to build the containers, to somehow manage them, to set up the structure. But today there is Docker, and because we care about all these standardizations and we try to be friendly with the community, we are moving from our custom-based containers to something that the community actually standardized on and is using for their own use. So Docker is probably the future of containers, but you never know in IT. And it can be something else. Docker may disappear, nobody knows, but it seems so. And the last part is Geardy. That's a tool by RedHat that will be actually at the heart of the next OpenShift, the next platform as a service that we are building. I created a small diagram. I hope it's readable a bit. I am not really great with the lines and stuff, but I hope it will make the picture and show the idea. So Geardy is like the heart of all the platform. It can be platform as a service, it can be your network, whatever you are trying to deploy, or start, or manage, some infrastructure. Geard will be there, and it talks or runs on host operating systems, and configures and manages them. It works in cooperation with some other provisioning tools like Chef, Puppet, it's up to you. But it provides a binding between the host operating system and the containers. And I should probably explain one more thing. So you have this picture where, this is very strong light. So you have this picture, which is like a picture, like diagram of what the machine looks like when you deploy it with Docker. So you have the server, that's the hardware. You have the operating system. On top of the operating system, you have the Docker engine. And on the one operating system, you have several applications deployed in the containers. This is a bit different from the classical virtualization, where you would have it switched back here, where you only share the hardware and the operating systems are deployed in separate environments. The containers run on top of one operating system. So there is one unfortunate thing. With containers, you share the kernel. So you cannot deploy using container Windows on Linux, because the kernel has to be the same. You are just virtualizing the processes, the system calls, not the hardware and the operating system. So Geard, once back again, these containers are completely isolated. So if you deploy an application, it cannot see the other applications on the machine. It just sees its own environment. It can be like Ubuntu on CentOS. It can be, I don't know, Arch Linux on Red Hat Enterprise Linux, whatever. It doesn't matter. But it will share the same kernel, but the processes deployed in the containers will not see each other. What Geard will do for you is to provide the bindings so the processes or the network connections can communicate with each other. That's described by the lines here. So you have two different containers on one machine, and you have to use some tool to actually provide the binding, the ability to talk to each other. So the processes can see each other, can send data, receive data. It also can, as same as on one machine, can bridge several containers deployed on different machines and different operating systems. So this is what Geard is about. But also, Geard can do very interesting thing. That's the main idea that I want to show you today is it can build your source code into an image or a container that can then be shipped or deployed somewhere else. So you, as a developer, you can create your own containers. You can create your own applications deployed in the containers, and then you can ship them to somebody else. Also, a very important thing is Docker is providing a layered file system. So if you are deploying, for example, Wildfly, is somebody using Wildfly? Oh, cool. Wildfly is the new application server by Red Hat. It's the rebranded JBoss application server. It is a certified JavaEE 7 application server. And if you are building, I will use it in the demo. You are building so for example, Wildfly on CentOS. What you do is you will take a CentOS image of the container, and you will put Wildfly on top of it. And then you can mix and match it. So if you will be then shipping your Wildfly, the Wildfly image will know that it needs the CentOS image. It will pull the CentOS image, and then it will stack itself on top of the image. It is important because if you have Wildfly, if you have Oracle, if you have IBM application servers, and they are all deployed on the same version of CentOS, you can have one CentOS image, and whenever you deploy a container with different application server, the underlying operating system image will be the same. So if CentOS image has something like 300 megabytes, and Wildfly image has something like 100 megabytes, and then the space taken on the disk is, the space is taken by these, and these containers like separated. So I will show you how to build a simple. I have 6 minutes left. That's so quick. 5 minutes. So I will show you how to build a new image, how we see it possible to build a new image. And during the time, we will have time to, you can ask the questions. Can you see this? I don't have here part of my screen. So this is the command that will actually be running inside the platform as a service. You can use it as a developer on your machine. And what it does is it will take a Java application from GitHub. That's the first part. And it will use the Wildfly 8 on CentOS image and will deploy and will build a new container that will be registered with my Docker instance on my machine. If I run it, it will work, probably. I'm using my MiFi because the Wi-Fi is not working for some reason. What's happening is it started a new container on my machine where it deployed the source code from the Git repository on the internet. And because it detected that it's Java application, it detected it's a Maven project, it is actually starting a Maven build inside the container. These containers are completely isolated from my main machine. So if I'm running this, you can see the whole build of Maven because the container is isolated, so it cannot see the cached artifacts of Maven on my main machine. The container is completely clean CentOS image with installed Wildfly on top of it. So this takes some time. I hope I will not run off my mobile data. And once this is finished, it will produce a WAR file. The WAR file will be the build application. It will know that if you want to start the image with this application, it needs the Wildfly on CentOS image. The Wildfly on CentOS image knows it needs the CentOS image. So if you build twice the same project, you will get 2 different images. But it will not take, I don't know, 400 megabytes or something for the operating system for the Wildfly and for the application. It will just add 2 megabytes or few megabytes for the application, and the Wildfly and the CentOS is shared for both of the applications. Then, if you want to share your application, your image with someone else, you can push it into the Docker repository. And this is also important that it's just the difference between the main image and the application image, because you will be pushing just the things that were built for the application, not the operating system and not Wildfly. This is already registered there, and it doesn't have to be shared again and again and again. So once this is done, we will continue. Now it's time for your questions because we have like 3 minutes left. Please.
So is Redshift going to accept any Docker container? If we have a Docker container, we'll be able to run it on OpenShift?
Yeah. So it will be automation on top of Docker. So the next version of OpenShift will be able to run Ubuntu. Then depends on what we will be supporting. We will be able to support you that the container is running and is available, but we will not be able to support your Ubuntu installation inside.
I see. And are you expecting us to take a general Ubuntu Docker, or will you provide a series of Dockers that we then can afford to build?
We are still like in the beginning phases of the development, so this is being talked about. So the application was built, and you can see that artifacts were deployed, root.var. So what I can do is to actually start the container. So I am saying Docker, run a container called Wildfly test and bind internal 8080 port to my local machine 8080 port. I'll go to my, you see there's nothing running on my 8080. Now, so I'm starting CentOS, Wildfly on CentOS, and it's done. And you can see that the application has been deployed and it's running there. I can take the application, I can push it to someone else, and he can run it the same way as I did here. He doesn't have to install Wildfly, he doesn't have to install any binaries on his system. The only thing that he needs to have is Docker installed, and Docker will handle everything for him. He just needs to know what image he wants to deploy. So the next thing I can show you is Docker PS. This will give you a list of the containers that are actually running on your machine. So I'm running Wildfly, and it's running for 40 seconds. And there are the list of the ports that are actually available in the application container. And you can see that my 8080 port on my machine, on all the IP addresses, is binded to the internal 8080 port. The next thing is we need to copy the ID of the container, and we can see what is actually happening inside the container. So you can see that we have two processes running. There is the PID somewhere visible, and you can see that there is a bash running somewhere. It's not very nice to see on the screen, but there is bash running, and inside the bash is Java process, and the Java process is the Wildfly, and there's nothing else running in the container. So this is completely isolated from my main machine. If I would start this image twice, then these two Wildflies, these two applications, will not be able to see each other, and I will need to allow it to see each other. And the last thing we can do is actually stop it. And this will stop the container, it will stop Wildfly, and then I will not be able to actually access the application. I have 0 minutes. We managed to go through, and the application is undeployed. And if I want to show you, for example, how this application looks like, I can ship you the image. You can install the image. You can start the application, and it will not in any way pollute your main machine. Everything will be contained inside Docker, inside the containers. You can just delete it, and it will be gone, and you can continue as before, and you can still see the application with all the artifacts, all the binaries, and everything that were hidden in the container. So, thank you very much for coming. I hope you enjoyed it. And if you have any questions, please come here. We didn't have much time for it, so I hope I will be able to answer it.